Okay, so these next set of problems, what we're going to be doing are um, interest problems. Okay, and so we will need some formulas for that. So I'm going to be using this formula sheet, okay, which has been published in the Resource Center here. So we're going to be using some of these formulas as we tackle these next set of problems. Okay, so let's look at our first problem here. It says to go on a summer trip, David borrows $500. He makes no payments until the end of 5 years. When he pays off the entire loan, the lender charges simple interest at an annual rate of 6%. Okay, how much total interest will David have to pay? What will the total repayment amount be, including interest? All right, so the key words to this problem is the word simple interest. Okay, so that's the formula we're going to be using for this problem. Okay, is the simple interest. So if we go back to our formula sheet here, okay, the simple interest is going to be this one here, I equals PRT. So that's the problem we're gonna the formula we're going to be using for these types of problems. I is equal to PRT. Okay, so I equals PRT. All right, so P is going to stand for the principal, okay, or the amount borrowed. Okay, R is going to stand for the rate. And then T is going to stand for time. Okay. A lot of times it's in years. Okay. Or year. Okay. So, and of course, I is talking about the interest, right? Particularly simple interest. Okay. So we're just going to apply this formula here. So we want to figure out how much total interest will David have to pay. Okay. So we have I is equal to PRT. All right. So P is the amount that he borrowed, $500. So that's what we're going to put in for P there. All right, so let me write it down here. So this is A. I is equal to PRT. All right, so P is either the principal or the amount borrowed, so that's the $500. The rate, okay, it's the annual rate of 6%, so we can need to convert that to a decimal, 0.06. And then time, right? We want to find out at the end of 5 years. All right, so we just put 5 for T. Okay, so when we multiply that out, we get $150. Okay, so that's how much total interest has occurred on his account. Okay, part B says, what will the total repayment amount be? Okay, total amount, repayment amount. So we just take the $500 that he borrowed and then add the 150 that has occurred on the interest. So that's a total of $650. Okay. Okay, so this one says Amy borrowed $6,000 from a lender that charged simple interest at an annual rate of 7%. When Amy paid off the loan, she paid 1260 or $1,260 in interest. How long was the loan for in years? Okay, so we're going to use the same formula we started to use. So that's going to be I is equal to PRT, right? So P again is the amount borrowed or the principal. So in this case, Amy borrowed 6,000. So we put 6,000 there. And then R is the rate. So the rate is 7%. And then T, I don't know. That's what we're looking for. But we do know I because it said that it had occurred 1260 in interest. So we put 1260 here. Okay. All right. And then so we just solve for T. So 6,000 times 0.07 is going to give us 420 times T and divide by 420 on both sides. So T gives us 3 years. All right, it says here Donna takes out a loan for her college tuition from a bank that charges simple interest at a rate of 14%. Her loan is $6,800 for 8 months. Assume each month is 1/12 of a year. Okay. Do not run any intermediate computations and round your final answer to the nearest cents. A, find the interest that will be owed after 8 months. And B, assuming Donna doesn't make any payments, find the amount owed after 8 months. All right, so again, let's read this as Donna takes out a loan for her college tuition from a bank that charges simple interest at an annual rate of 14%. Her loan is for $6,800 for 8 months. Assume each month is 1/12 of a year. Find the interest that will be owed after 8 months. Assuming Donna doesn't make any payments, find the amount owed after 8 months. Okay, so again, we're still going to be using the formula I is equal to PRT. Why? Because it says simple interest, and that's the simple interest formula. Okay, so when the principal or the amount borrowed is $6,800, so we put that there. Okay, the rate is 14%. So 0.14. Now this part is tricky because it's 1/12 of a year, right? A lot of times T is in years and this is in months. So what we need to do is just multiply 8 times 1/12. Okay, which gives us 8 over 12. Because again, it's not the whole year, it's only part of a year. Okay, so we're going to multiply this by 8 over 12. Okay, and so when we do that, we get $634 and 67 cents. Okay. And then we just need to add this to what she already has. So this loan is 6,800, add the 634.67, and that gives us a total of 7,434.67. Okay, so let's go through this problem. It says Justin took out a loan for 270 days and was charged simple interest at an annual rate of 14.6%. The total interest he paid on the loan was $378. How much money did Justin borrow? Assume that there are 365 days in a year and do not round any intermediate computations. Okay, so you don't want to round until the very end because um, the more you round at the beginning, then the further you are, you'll be from your true answer. Okay. Okay, so again, we'll start with I is equal to PRT, right? And what are we looking for? We're looking for the total interest. How much money did Justin borrow? So we're looking for P, right? This is what we're looking for. Okay, so it says here the total interest he paid was 378. So 378 is going to be for I. I don't know what P is. That's what we're looking for. R is 14.6%. So that's 0.146. And then T is says 270 days, right? Assume that there are 365 days in a year, so that's going to be 270. Okay. Multiply that by 1 over 365 or 270 over 365. So that's going to be our time. It's going to be 270 over 365. Okay. All right, and now we just solve for P. So we're going to get, if we multiply these guys together, we're going to have P times 0.108. Okay. And then we still have the 378 on the left. Then we're going to divide both sides by 0.108. And then these guys will cancel. Okay, so that gives us $3,500. Okay, so the next set of problems we're going to talk about is are dealing with compound interest. And there are two types of formulas we need to know for this. Okay, so the first formula is the balance is equal to principal times 1 plus the rate raised to time. And that actually corresponds to the bottom formula here. All right, this is the same thing. It's the initial. The only difference is now you have a plus or minus for the percent increase or decrease. And this one is just plus the rate. Okay, so that's the big difference. Okay, in regards to those ones, but they're both dealing with, well, specifically the first one dealing with compound interest that's been compounded only once a year. The other one is another type of compound interest, this one here, and this is when something is being compounded more than once a year. So again, we'll be dealing with those types of formulas. Okay, so let's look at here. So this one says, suppose Chris places $6,000 in an account that pays 16% compounded each year. Assume that no withdrawals are made from the account. Okay, do not do any rounding. So it wants us to find the amount in the account at the end of 1 year and then find the amount in the account at the end of 2 years. Okay. So, like I said, let me pause here for a second. Okay, so this is one of the types of compound interest. So this is going to be compounded each year. So we want to use this formula here. Okay. So again, let's read this. It says, suppose Chris places $6,000 in an account that pays 16% interest compounded each year. Assume that no withdrawals are made from the account. Find the amount in the account at the end of 1 year. Find the amount in the account at the end of 2 years. Okay. All right. So again, the principal of the amount borrowed is going to be $6,000. So let's put that there. Okay. And then we have the 1 plus the rate. The rate is 16%. So we need to convert that to a decimal, 0.16. Okay. And we just want for the first year. So T is 1. Okay. So we're using compound interest and see what we get after the first year. Okay, so basically what compound interest does is whatever you got for year one, it's going to use that one to calculate year two. Okay, and then to calculate year three, it's going to use the one's previous year to calculate year three, so on and so forth. So that's how compound interest works. Okay, so when we put this in the calculator, so in this case, make sure when you do, because this is some students will get will put the correct information down, but they get the wrong answer because they're not following PEMDAS. So we needed the parentheses first, and then the exponents. Okay, so in this case, we're going to focus on inside the parentheses. So that's going to be 1 plus 0.16. So that's the 1.16. And then we multiply by 6,000. Okay, if you don't do it in order, you're not going to get the correct answer. So when we do that, we get 6960. Okay. All right. The second one here is the same thing, but this time it's at the end of 2 years. So we use the same formula. So we have 6,000, 1 plus 0.16. But instead of putting 1 as my exponent, I'm going to put 2. Okay. So again, here we get 1.16. And this time it's going to be squared and then multiplied by $6,000. Okay. So when we do that, we get $8,073.60. Okay, so here it says a city has a population of 370,000 people. Suppose that each year the population grows by 4%. What will the population be after 10 years? All right, so again, we're going to just use the same formula that we used on the previous problem. Just going to copy this and paste it. All right. So just FYI, if it did say something in decreasing, then I would use the other formula because it has that percent increase and decrease. So I would use this one here. Okay. If it has something about decreasing, so you will subtract from 1 to do that or 100%. Okay. All right. So, okay. So here we would have 370,000. Okay. And then times that by 1 plus 0.04 and raised to the 10th. Okay. So again, we want to do inside the parentheses first and then raise it to the power of 10 and then multiply by 370,000. When we do that, we get 547,690. Okay. So let me just go back here and give me a second here. Okay, so again, what I was referring to is if it had something, if it talked about like say the growth decrease, so if it decreased by the 4%, then we would use this one here because this one's talking about 1 plus or 1 minus, so there'll be 1 minus 0.04, okay, because it had decreased by 4%, right? And everything would be the same. Okay, so that's what I mean by that. Okay. If it had mentioned decrease or depreciating in value or something like that. Okay, so those are nice because they're dealing with being compounded only annually. So what happens when we are dealing with um, items that are compounded more than once? So let's go to that. Okay, so the next set of problems we're going to be dealing with is compound interest, but this one is being compounded more than once a year. So the formula for that is this one here. It's going to be the balance equals the principal times 1 plus the interest rate over the number of times compounded each year, and then raised to the number of times compounded each year times that by the number of years. So this is the formula we will be using for the next set of problems here. Go to our problem here. All right, so here it says prices are saving up to a family vacation in 3 years, then invest $2,500 into account with an annual interest rate of 1.26% compounded quarterly. Okay. Assuming no withdrawals are made, how much money is in the prices account after 3 years? How much interest is earned on the prices investment after 3 years? All right, so again, this is a compound interest is being compounded more than once a year. How do I know? Well, again, it tells us it's compounded quarterly. Okay. So again, it says the prices are saving up to go on a family vacation in 3 years. They invest $2,500 into an account with an annual interest rate of 1.26% compounded quarterly. So what does quarterly mean? How many times is that per year? Exactly. So quarterly means it's going to be compounded 4 times a year. What about monthly? How much is that? How many times is that per year? Okay, great. 12. Okay, what about daily? Good. 365. And then how about semi-annual? Good, right? So that'll be 2 times a year, right? So you need to be careful when you read these problems because it's going to tell us exactly how many times it's going to be compounded. Okay? So I'll just be aware of that. Okay, so we want to find out, again, we're going to be using this formula here. We want to find out, assuming no more draws are made, how much money is in the prices account after 3 years. Okay, so the principal or the amount borrowed is going to be the $2,500. Okay, so $2,500 has been invested into the account. So we have one plus the interest rate. The interest rate is 1.26%. So that's going to be 0.012, again, 0.0126. Okay. And the number of times compounded is quarterly, so that's going to be 4. Okay. And then that's going to be raised to the number of times compounded, that's 4, times that by the number of years. So that's it's going to be after 3 years. So 3 here. Okay. All right. So 4 times 3 is going to give us 12. And again, I want to use PEMDAS, so I'm going to calculate inside the parentheses first. Okay. And then raise it to the power of 12. Okay. So I have my calculator here. So again, I'm going to do inside the parentheses first. So I'm going to get 0.0126 divided by 4 gives me this here, and then I need to add the 1. Okay, that gives me this next. Then I need to raise. So I did the parentheses first. Now I need to do the exponent. So that's going to do raise it to the 12th power. So we're going to multiply this or raise it to the 12th power. We get this much. Okay. And the last step is we have to multiply it by the 2,500. Okay. So we get 25.96 and 15 cents. So let's write that down. So 25.96 and 15 cents. Okay. How much interest is earned on the prices investment after 3 years? Well, we can just take that 25.96 and 15 cents and then subtract it by the $2,500 that was started when the prices were investing. So subtract this by 2,500. Okay. So we get $96.15. So that's how much money has occurred through compound interest during that time. Okay, I would do another problem like this, but we are running out of time, so I want to get to these next two real quick. Actually, you know what? All right, let's try one more of these. We have some time here. Okay, so let me pause this. All right, so I made this one up here similar to the previous one we just did. So this one is $3,500 investing over 5 years, and it's compounded monthly at a rate of 2.25%. Okay, see if you can figure out the total amount after the 5 years. Okay, so let's go through this. So again, I'm going to be using we're going to be using the same formula here. All right. So, so we're going to have the $3,500 now. And then we're going to have one plus the interest rate is 2.25%. So that's going to be 0.0225, excuse me, divided by 12. Okay. And because it says compounded monthly, right? So we divide by 12. So that's going to be raised to 12 times 5, okay, which is going to give me 60 here. All right. So let's put this in the calculator. All right. So 0.0225 divided by 12, enter, add the 1, enter. Then we need to raise this to the power of 60, enter. All right, and then we're going to multiply this by 3,500. Okay. So we get 39.16 and 34 cents. So notice I didn't round anything. I just kept all the values so that it doesn't mess up my true answer here. Okay, so again, we get $3,916.34. Okay, the last formula we're going to be learning here, all right, this deals with this problem here. Okay, so I have published the last formula sheet in the resources, all right, and this is final formula sheet part 3 that I have included. Okay, and so which looks like this. All right, so it has all these conversions. But we want to look specifically at number 4 on the right column here. A is equal to PERT. Okay, so that's what we're going to be using. Now you might be wondering what the heck this E is. Well, think about pi, right? Pi is just a number. So if I put this in a calculator, pi is going to give us 3.14. Well, E, the letter E is the same thing. It represents a number. So if I put this in there, so E to the first power, that's going to give us this much. So it's a 2.718, etc. Okay. So this number has occurred so much, so it has its own um, symbol for it. Okay. All right. So that's what we're going to be doing on this part. Okay. So let's write this down. So it's going to be A is equal to PE raised to the RT. Okay. All right. Now, how do I know that this is the formula we're going to be using? And the key word here is continuously. So when it says that word, okay, when it says the word continuously, you need to use this formula. Okay. So Money Savers Bank offers a savings account that earns 8% interest compounded continuously. If Pablo deposits $3,800, how much will he have in the account after 2 years, assuming he makes no withdrawals? All right, okay, so we just plug in our information. So P in this case is 3,800, okay? And then we have E raised to the RT. So R is the rate, okay, which was 8%. So that's going to be 0.08 times that by uh T. So in this case, 2, right? 2 years. Okay. So this little spot here is going to give us 0.16. Okay. So we just take $3,800, multiply that by 0.16. Okay. And actually, no, I take it back. There's an E there. So it's E raised to the 0.16. There we go. Okay. So again, I need to do my order operations when I do this. If I don't follow this, then it's gonna mark it wrong. So we're gonna use second E and raise that to 0.16. Okay. And then we're gonna press enter and we get this number here. And then we're gonna multiply it by the 3800. So again, notice I don't do any rounding. Let me try it again. All right, here we go. All right, so we get $4,459 and 34 cents.